compositions. And then 800. This was about 6. This was 94. And then just above at 800, 867, that's also 8. That was 67. This is 77, and this was so we had identified those endpoints last time. That was 93. All right. So I want to do these again in a slightly different order. Just to kind of rehearse what we did last time. So looking just at the eutectic, 71.9 weight percent silver at 800 and 700 and 300. So at 800, just have liquid. And the concentration of liquid is the same as my overall composition, 71.9. So this is 800, there we go. I just have liquid. The liquid has 71.9 weight percent silver. As a composition, remember, always use weight percent with composition. It's all liquid. We really can't see anything under the microscope because you can't look at a liquid. As that eutectic composition is cooled through 779, all of the liquid transforms to this eutectic microstructure that we talked about. And the equation or the reaction is that liquid at 71.9 weight percent silver, when it's cooled through 779C, it transforms to alpha with 8 weight percent silver and beta with 91.2 weight percent silver. So we only have liquid at that composition as we're going through that temperature. So all of what we get is this eutectic, and the microstructure is layers of the two phases. Kind of looks like a thumbprint or a zebra. So when we get to 700, then now we have alpha and beta. The alpha, we're just below, looks like our alpha composition is 6 weight percent silver, and the beta is 94, wait, 93. So those are the two endpoints on this line, 700-degree line. Endpoints at 6 and 93. And we use the lever to calculate relative amount of each. There's alpha, it's at 6. There's beta, it's at 93. And my overall composition is the fulcrum, 71.9. So the percent alpha is the length on the other side, 93 minus 71.9, over the total length, 93 minus 6, and we calculated that last time to be 25% alpha and 75% beta. Those two should add up to 100%. And so the microstructure is all eutectic. So these black lines, you could say, are alpha, and the white spaces in between are beta. And they start out in the liquid all over the place, and so, you know, kind of random areas. All right, now, if we take that composition and we cool it further to 300 degrees, we're still in the alpha and beta range, but now the alpha has gotten to be pretty much pure copper, 0.8% silver. And the beta is pretty close. Let's say it's 97. Those are these endpoints here. That's 0, and that's 90, is it 97? It really is just, you know, kind of an estimating from the diagram. What are the relative amounts of each? Percent alpha is 97 minus 71.9 over 97 minus 0. And it usually isn't that much different than what it was. So we're at 26%. Alpha and 74% beta. So slightly different amounts of alpha and beta. The layers of alpha have just gotten thicker, and the layers of beta have gotten thinner. But not that much different, and it would look just like seven. Okay?
I guess those diagrams, if it's at 700 degrees C though and not 779, why does the structure look like that?
Because it was formed, and the structure's not going to change. I mean, the layers aren't going to change. What will happen is they might, one of the phases will get thinner and the other thicker, but the arrangement of those phases won't change.
Okay.
Okay? So 28% silver, that one is called a hypo. Eutectic, because it has less than the eutectic composition. So at 800 degrees, I've got liquid and alpha. And my two endpoints tell me the composition. So got liquid and alpha, and the alpha has 8 weight percent Ag, and the liquid has 67 weight percent Ag. So to calculate the relative amounts, my line goes from 8 for alpha to 67 for liquid, and I'm at 20. And so the percent alpha is 67 minus 20 over 67 minus 8. And we calculated that. %80 alpha and 20%. So if I could look at this, even though it's liquid, I'm going to have 20% liquid, and then I'm going to have grains of alpha in the liquid. And I've got a lot of alpha, 80%. I'm not going to use colors this time to show you locations. Now when this cools through the eutectic, wherever there's liquid, I'm going to get that eutectic structure, those layers of alpha and beta. So once I cross, I have alpha and beta,